Hello everyone, I am Deepak M from 7th semester studying in CSCI department in Sri Venkateshwara College of Engineering. Today I will be speaking about the topic clustering. What is clustering? Supervised and unsupervised classification. Types of clustering algorithms. Most common techniques, areas of application, and all this will be discussed. Clustering definition. The process of grouping similar items together. Clusters should be very similar to each other but should be very different from the objects of other clusters slash other clusters. We can say that intra-cluster similarity between objects is high and inter-cluster similarity is low. Important human activity used in childhood is discussing between the items such as cars, cats, animals and etc. Supervised and unsupervised classification. What is classification? Type of clustering algorithms. Clustering has been a popular area of research. Several methods and techniques have been developed to determine natural grouping among the objects. Jain A.K. Murthy, MN and Flying PJ data clusterings, a survey ACM computing service done in 1999. These are all the types of clustering done here. Hierarchical methods, partitioning methods, grid-based methods, clustering algorithms used in machine learning, algorithms for high-dimensional data, classification versus clustering. Classification, supervised learning, learns a method for predicting the instance class from pre-labeled classified instances. Unsupervised learning finds natural grouping of instances given unlabeled data. Clustering valuation done based on the manual inspection, benchmarking on existing labels, cluster quality measures, distance measures, high similarity within a cluster, low across the clusters. Distance function, simplest case. One numeric attribute A is distance xy is equal to a of x minus a of y. Several numeric attributes such as distance xy is equal to Euclidean distance between the x and y. Are all attributes equally important? Weighting the attributes might be done. Simple clustering works with numeric data only. Pick a number k of cluster centers at random. Assign every item to be its nearest cluster center. Example using Euclidean distance. Move each cluster center to the mean of its assigned items. Repeat steps 2, 3 until coverage. Change in cluster assignments a threshold. The initial cluster sentence are all this randomly in this image. You can see this step 1. Step 2, assign each point to the closest cluster center. Step 3, move each cluster center to the mean of each cluster. Reassign points closest to the different new cluster center. Which points are reassigned? 3 points with animation. Step 4. Step 4b is recompute cluster means. Step 5 where move cluster sentence to cluster means. Squared error criterion. The K-means algorithm with a Euclidean distance measure is equivalent to a minimization of the squared error criterion, where E is the sum of square error for all objects in the database, P is the point in space corresponding to the given object, and Mi is the center of cluster Ci. P minus Mi denotes the distance of data object cluster center it belongs to. This therefore makes the clusters as compact as separate as possible. Pros and cons of K-means. K-means works well when data form compact clouds well separated from one another. Method is scalable and quite efficient for large data sets with complexity O, where K is the number of clusters, N is the number of objects, and T is the number of iterations required. Usually T is greater than less than N, and K is less than N. can only be applied where the mean of a cluster is defined. Where there are categorical data, this may not be possible. Users may not be able to select a good value. Algorithm is sensitive to noise, outlier point, and can influence the main attribute of the value significance. K means variation. K mediates instead of mean use medians of each cluster. Mean of 1, 3, 5, 7, 9 is 5. For larger databases, using K medians. This method is less sensitive to outliers than K means. Each cluster is represented by most central object in the cluster. We still minimize the sum of dissimilarities between each object and its cluster reference point. K-medoids algorithm. Randomly choose k of the n data objects as medoids. Repeat. Assign each of the remaining objects to the cluster represented by the most similar medoid. Randomly choose a non-medoid object. Consider each of the current medoids, OJ. Compute the total cost S of swapping OJ with and includes the cost contributions of reassigning non-medoid objects caused by the swap. If S is greater than 0, then swap of OJ with random to form the set of k medoids until no change is found. Evaluating cost of swapping medoids. These are the steps: reassign to OI, reassign to O random, no change, assign to O random. These are all the symbols: data object, cluster center, before swapping, after swapping. Let me discuss about the total cost of the swap. Each reassignment determined as above causes a difference in square error E to be contributed to the cost function. The difference may be positive or negative. The total cost of swapping S is the cost of all cost from non-medioid objects. If total is negative, the swap is worthwhile doing. Let me tell the advantages and disadvantages of k-means clustering. Advantages are simple, understandable, items automatically assigned to clusters. Disadvantages are must pick number of clusters beforehand, all items forced into cluster, too sensitive to outliers since an object with an extremely large value may substantially distort the D of data. Hierarchical clustering has types like agglomerative clustering, which start with simple instance clusters, and divisive clustering start with one universal cluster. Both these methods present and produce a dendrogram. This is the partial superior region of the clustering where a two-dimensional image of supervised can be seen here. Two-dimensional image of different zones of both claim a data point. More than two clusters can claim as also common data point. What are the research problems we can find in this clustering? Effective and efficient methods of clustering, scalability, handling types of data, handling complex multidimensional data, complex shapes of clusters, subspace clustering, cluster overlapping, etc. These are examples of the clustering applications such as marketing, astronomy, earthquake studies, genomics. See, I have telling summary where I have discussed you unsupervised many approaches, K means K meteorites hierarchical cluster, and you can also revise many other things from the clustering. Thank you. Please like.